Well, look at that. It's an S550 Mustang front spindle with a CV joint. Well, too bad it doesn't work. Welcome to episode 9 of the all-wheel drive Mustang project. For the last couple of months I've been focusing on the front spindle design, and critical to that is choosing the front hub and the corresponding outer CV joint. The diameter of the CV joint is very important when it comes to designing the spindle. The diameter basically affects the clearance to the ball joint and to the strut mount. And I went through a lot of kind of trials and tribulations trying to pick the front hub. And I want to kind of go through that with you and kind of explain my thought process. The original plan going back several years was to use this hub. This is from a 2010 or 11 Ranger, and it has a couple of good properties to it. One is it's the correct bolt pattern. It's the wrong studs. I think they're 1/2 inch versus M14, but it does have the correct diameter for the wheels, and the diameter for the disc brake is a little big, but it could be machined down to fit the disc brakes. It also has a built-in ABS sensor, but what I found out recently is that it really has too many pulses. In one of my earlier videos I did some experiments that show that the stock Mustang GT has 50 pulses per rev, the MR spindles have 48, and these Ranger and Explorer hubs have 54, which would be an 8% difference, and I'm concerned that would be too much. But a big advantage of this generation of spindles is to use a 27 spline CV joint. And there are just lots and lots of CV joints with a 27 spline. And for example, here's our few. And there's really a lot more than this. This is from a Focus, and this is 82 millimeters in diameter. This is actually from a newer Dodge Charger, which actually fits perfectly fine in the Ranger bearing assembly, and is about 80 millimeters in diameter. And this is from a early 2000s Explorer, and also fits just fine. And so the beauty of this 27 spline, and why I picked this a couple of years ago, was there's just a plethora. Even some Astro vans use the same spline. There's actually an 86 millimeter CV joint from a Ford Contour that I was going to try to get, that might be kind of an in-between solution. But ultimately there's a couple of deal breakers that has got me away from this hub. One is, as I already mentioned, the 54 pulses from the built-in ABS sensor, and second is the kind of offset distance. The distance from the flange here of the wheel to where it mounts is really quite large, and starts to affect my design of my actual spindle. So taking all that into account, and with the new revelation that the MR hubs come with a bolt-on hub, I thought, well, let's move on from this into a different hub that has some better properties. So this is a hub off of a newer 2018 Mustang with a Magna Ride suspension, right? And there's all kinds of buzz around the internet about how this hub not only is a bolt-on and it's self-supporting and it's stiffer and has all kinds of good properties, but it also has splines in it. And whenever I bring up that I'm going to make an all-wheel drive S550 Mustang, everybody instantly points out, oh, Ford is going to make an all-wheel drive one. Look at the hubs from a GT350 or a Magna Ride Mustang. They have splines in there. And so I thought I would fully investigate this to make sure I wasn't being stupid to not use this. I was pretty quickly of the opinion that the splines are not adequate, but I couldn't help myself and fully research it. It does look super elegant. Obviously it's the right bolt pattern, it's got the right studs, it obviously has the right diameters here for the brakes. I mean, it has just all kinds of good features. So I fully exhausted, we'll say, will this work? And the first question is, will the splines work? But you can kind of see there how short the splines are. They're only about 0.9 long. And I did some calculations, and if you were to fully engage that spline, it might be on the hairy edge of actually being adequate. But it's hard to see. Yeah, right there you can see. I put some grease in there to kind of create a witness mark, and I installed one of the CV joints that actually fit this hub. And you can see it only engages about 1/2 to 2/3 of the splines without doing some sort of modification. So, but I still didn't give up. I thought, okay, this is just too elegant, right? The hub fits the wheels, it's the right bolt pattern, it's meant for a Mustang, it's got the right pulse count. I'm not going to give up that easy, right? So the spline is really too short, but maybe it's good for a first go around. So, okay, so then once you pick that, what CV joints are available that actually fit it, right? Well, first thing I got was the front from an Explorer, this CV joint here. Well, to say this is mammoth and comically huge and overkill is an understatement. It's 100 millimeters in diameter and obviously could take just tons of power, but would make my spindle just really, really big. So that quickly got thrown out. The next one is that actually the 2008 and newer Tauruses come with kind of a in-between size CV joint. It's about 91 millimeters in diameter, and also more importantly has a nice shaft size that would easily handle the power. Now the picture I showed at the front of the video, kind of as a little clickbait, shows this CV joint, which is from the back of an Explorer, the back of like a 2011 through like 2019 Explorer. And you know, on the surface it looks pretty interesting. As you saw in that picture, it almost fits. It really doesn't, but it almost fits. But it's only 73 millimeters in diameter. And here is the star or the inner race out of that CV joint. And it's really, the shaft is really small. Like it's ATV small. I measured this, I forget the exact numbers right now, but it basically, if you assume some reasonable material, it can only handle about 500 foot-pounds of torque, which I need at least double that to be safe, if not triple. And so even if I made the shafts out of something really awesome like 300M, maybe it would get to 700 foot-pounds of torque. And I'm not going to go through all the effort of putting all this together to have some designed-in weak link. Now, if I wanted just say I made an all-wheel drive Mustang and never put any power to the front, or at least not, you know, go to the drag strip and just putt around, it probably would work. Obviously, you know, they put power to the back of an Explorer, but this really just shows how little power they put to the back of the front-wheel drive-based Explorers. This is just a minuscule CV joint. Like I said, most modern, you know, side-by-sides have a bigger CV joint than this. So now what do, right? Basically, you know, once again, this hub has some good properties where the bolt pattern's right, it fits a Mustang, blah, 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 blah. But maybe this CV joint would be okay. But when you plug it in, it only engages like 1/2 or 2/3 of the already tiny spline. And to make that better, you'd have to then machine away some of this to get full insertion, if you will, of the spline, to try to get the spline to come out proud of this surface to really maximize your spline interface. Well, that probably works, and I went down that path a little bit. But I thought to myself, well, what hub would accept these splines that actually has, you know, enough spline to be safe? Well, then that's this hub right here. And so this is the hub from a 2011 and newer Explorer. Well, 2011 through 19, I believe. I don't think they changed after that. But as you can see, it's very similar to the MR hub. But most importantly, the spline goes all the way through. And every car I've seen where the axle is actually driven, the spline goes almost all the way through, or through most of it. And once again, reinforcing my theory that this spline is never meant to be driven. It's for some manufacturing purpose. So this does have the right bolt pattern. It's the wrong stud size, but you could push those out and change it. the wheel and the brake diameter are wrong, but they're small. So you could, you know, make a hub-centric ring here to put on this to get the wheels and the brake rotor to be hub-centric. And it does have the correct number of pulses in here. So this would have been is and would be a very viable option. But what's so special about these? Actually, basically, it seems like only Ford uses in the Taurus and Explorer use this kind of oddball 0.75 module 38 tooth spline. This is the extent of the CV joints that are available that I could research that actually fit. They're pretty limited, and so that got me down to, well, what about other cars? What about other hubs? So brainstorming some more, I thought, well, what other hub could I use? What has the right bolt pattern? What's used in an all-wheel drive car? You know, and I thought, well, what am I kind of trying to go after here? Well, I'm trying to make an American V8 GT-R. So why not use a GT-R front hub? And that's what this is. So this is an R35 GT-R front hub. And so, well, what does it have for good features? Well, it is the right bolt pattern, but it's the wrong, these are M12 studs, not M14s. And it does have the good property of this offset is really tiny. Actually, it's the smallest of all of them that I've been researching. And I did verify it has the right pulse count in the ABS sensor. It's got 48 pulses. And it's a nice compact size. And so I thought, well, this is kind of a winner. And I did a lot of research on this. Couple things. One is it said it is an M12 stud, and there is very little meat here. And I'm a little concerned if I were to open that up to press in Mustang style M14 studs that there wouldn't be a lot of meat left. But maybe that would have been okay. So now you go down to the same road of what CV joint do you use? Well, here is a GT-R CV joint, R35. Matter of fact, well, this is actually from like an Infiniti, but based on the Nissan part number, this CV joint is used on virtually everything. Every rear drive based Nissan, like the FX35, the G35, G37, the R35 GT-R, it's used on everything. And the axles are different because they're different lengths, but the actual joint is the same on all those vehicles. And it's a 27 spline, but it's a metric 27 spline, so it's a one module, so it's actually smaller than like the Explorer hub I talked about earlier. And so this is an 80 millimeter joint, which kind of is a little on the small side, but I thought, well, they're used in GT-Rs. It must be maybe okay, at least for some power level. And here's the rest of it. So I pulled it apart, and here's the actual shaft that it plugs into that CV joint. And it is bigger than the rear Explorer CV axle that I dismissed earlier. And doing some math here, this will handle about 1,000 to maybe 1,200 foot-pounds of torque. On the edge of being okay, maybe even okay, to be honest. And I really like this hub, and this would be a good backup plan for sure. And I like this one better than the Explorer, to be honest, because there's some more CV joints available. This metric spline isn't super popular, the 27 spline, but there are some other bigger joints available if you look really hard. And obviously there's upgrades available for R35s that make good power. So I really like actually this hub. But going through all this, all of a sudden it dawned on me and I came to what I'm actually going to do. So okay, after looking at what I felt were countless hubs and CV joints and just obsessing over this, none of them were slam dunks. The GT-R hub was probably the closest. Second best was going to be the 2011 and newer Explorer hub was a close second. But none of them were just a slam dunk. And I thought, there's got to be something better, and I went back and looked at the MR hub again. Could I machine the CV joints to get more interface? And I'm thinking, well, is there any other car on the planet that has, a unit bearing that has the Mustang bolt pattern that, is an independent, type suspension? And I thought, well, I hadn't dawned on this before, But what about the rear hub from a S550 Mustang? You know, I had kind of discounted it because I always assumed that the CV joint was going to be way too big. And, you know, obviously I have a Mustang GT. You look back there and the CV joint is way too big. But I thought, you know, I never actually looked at like what are the V6 and the EcoBoost Mustangs. Do they use a smaller axle? So I call up the local wrecking yard. Well, sure enough, it all comes together. And this is the direction I'm going to go. So, this is the world's rustiest because it came from Minnesota, but I just wanted to get some cheap hubs to look at. But this is a hub from, basically a rear hub is the key, from a 2015 and newer, an S550 Mustang. And of course by design it has the right bolt pattern, it has the M14 studs in it, it has the correct diameter for hub-centric wheels and for the brake disc, all kinds of good stuff. And of course it has splines all the way through because it's meant to take all kinds of power. And it's a little bit bigger, but it has a reasonable offset. And I did verify that it has 48 pulses per revolution. And I thought, well, awesome, that's great. But the question is, it's a metric 1 module 32 spline, spline. And that seems to be somewhat odd, and for sure odd for front-wheel drive. It's used on quite a few Nissans. Matter of fact, this is what's used on the rear of a R35 GT-R and 300ZXs and a few other cars. I'm not saying I found every possible application, but the only application I found that uses this spline on the front is a early 2000s Nissan minivan, or the Mercury equivalent. But they have a pretty big CV joint. But it turns out, here you go. This is the CV axle from a V6 S550 Mustang. And in pictures it looks like it's really wide, but it actually isn't. This little dust shield kind of is deceiving. And it's 90 millimeters in diameter, which is like a perfect size. And I actually have another one taken apart already. The axle is plenty beefy and will handle, of course, all the torque I could ever throw towards the front because it basically can handle an EcoBoost in the back. And so it's like, wow, this is just, why didn't I think about this earlier? Maybe the only drawback is it's not a self-supporting bearing in the sense that basically this edge is not rolled over. So if you don't have a CV joint in here, this will just fall off, you know. So you have to have a CV joint in at all times. And there maybe is some question about, is this as stiff as the MR hub? Meaning, you know, when it comes to like camber movement and brake knockback. Maybe not, I don't know. But I had to make a decision, and this has so many good qualities that this is what I'm doing. Plus, unlike the Explorer solution, the nut ends up being completely recessed in here, and so it doesn't affect the wheels at all. And so that is that. That is what I'm going to do. All that to basically just use a stock Mustang part once again. So it's going to work out, I think, really well. And actually what's really interesting is the inner CV joint. So this is another V6 rear axle, and what's really interesting, what I never realized, is the inner CV joint is not a tripod style. It's actually a plunging 6-ball, which is really good. It's a really strong joint. And so I'm not certain yet, but I might try to actually use this as the inner front joint. It's got tons of articulation and tons of travel. And maybe just try to remachine this and respline it, the same thing I did on the main shaft of the transmission. That for sure I think would work on the passenger side where it would plug directly into the diff. This is really massive here, there's plenty of stock. How I would incorporate that on the driver's side where I need a jack shaft, I'm not sure yet, but it's definitely worth investigating. Once again, it's only about 90 millimeters in diameter, and so it's a really nice size. The current plan is to use one of these, which is basically a 100 millimeter GKN, CV joint used on all kinds of Volkswagens and Porsches and Mercurs for that matter. This is what I'm using on the front of my all-wheel drive V8 Mercur, along with Ranger outer joints, 27 spline outer joints, and they've been just completely bulletproof. So this is my original plan, and probably still is the plan, but this is really intriguing and requires some further investigation. Well, that's a wrap on episode 9. I hope you found that interesting. You know, it isn't always obvious the direction. You know, you basically have infinite options when it comes to some of these decisions on car projects or projects in general. And hope you found it interesting how I went down and meandered around to come back full circle to, I think, is a pretty good solution. Starting to make chips this week actually on the spindles. So the next video will be the actual fabrication of the front spindles. And the new goal, you know, unfortunately, you know, summers kind of go fast here in Minnesota, and the project's taking a little longer than I thought. I'm having a blast doing it. I'm actually having more fun making these videos than I thought I would, and I'm more excited than ever. But the reality is, you know, with family and life, it's taking a little longer than I thought. So the new goal is to get the car on the wheels, you know, by this fall. Not in all-wheel drive, but get the transmission in, get the shifter and the clutch, and get the rear drive shaft working. The transfer case will be in the car, the bump will be in the floor, the the transmission crossmember will be installed, and then the key here is the front spindles will be installed and the rack will be relocated. Basically everything but the front oil pan and the front diff and axles, which there's just no way I can get that all done by, say, November. But that will allow me to drive it around, you know, make sure the transmission works, make sure the front suspension geometry is good, etc., etc. As far as the transmission goes, it did get boxed up this week and got shipped out to Texas Drivetrain Performance. They're going to put it together for me and make sure everything was good, and I should have it back in a couple of weeks, and I'm going to get that installed and start working on the shifter. But like I said, in the meantime, I'm making chips on the spindles, and that'll be the update for the next video.